All right. Thank you guys for being here. I'm glad I'm not the talk of the day. All right. So thank you, Jim, for the great introduction. Thank you, sponsors, for making this happen, and for the daycare especially. So there we go. All right. So thank you for the introduction. Kind of a couple more words. So I'm originally from Siberia. Now live in Washington, D.C., but Siberian in my heart. I've been doing application security for 8 years now, and before I was a developer writing code in ActionScript, if anybody remembers what that was, in the world of Flash. So I guess I keep up with the script-type languages. And now I'm also working on my PhD, of course, about security and JavaScript and frameworks. And I do have a professional Twitter account. Don't confuse my last names, Peguero, Dmitrieva, originally. And I also now became a mother of a 9-month-old girl who's here. So that's awesome that I'm still able to work and travel. So security is important. And yes, in my kind of wishful world, I'm a ballroom dancer. That's what I would do if that made as much money as security, but, you know. So today we're going to talk about JavaScript one more time. Who here has written JavaScript? Who does it like, all right, awesome, yeah. And then who has written in React? Oh, wow, thank you. That's pretty awesome, cool. So we're going to talk a little bit about the state of JavaScript security, and specifically common vulnerabilities and the vulnerabilities in the frameworks, or kind of how the use of the frameworks change what we do in JavaScript. And then we'll switch to React and look at a couple problems with the framework, a couple vulnerabilities, things, the mistakes that developers make with it. And yeah, I'll have some demos that will hopefully work. So JavaScript, to kind of re-quote one of the things I saw on Twitter is that JavaScript is a great language, but sometimes it makes me say, screw this shit, except I don't know what this means in this context. So what is the state of JavaScript security today, or JavaScript field today? And yeah, there are more frameworks than there are applications. And note that this quote was in 2012, and we're in 2018, and there are even more frameworks. And what do we do with that? Well, yeah, I don't know. Because in 2004, this is how we wrote code, right? And today, well, this is 2014, right? This is what happens. So while I'm enjoying here in Hawaii, a couple weeks, I come back, and I don't know what's going to be the next JavaScript framework. Probably everything is going to be outdated by then. So what about the frameworks? The good. Yes, they allow us to develop everything better, faster, because you just run, you have your boilerplate, and you run 2 lines of code, and you run your React script start, and everything magically works, and you don't know where it's deployed and how, but it works, right? From the security reviewer perspective, it's much easier to review the code if you know if you're familiar with the idioms, right? If you know what you're reviewing, which has a pretty high learning curve. The applications are safer if their framework is safer, right? So kind of we basically offload this responsibility to the framework somewhat. The bad, well, yeah, as I said, steep learning curve. The bugs are sometimes harder to find if you don't know what you're looking for, or they're hidden in the hundreds of dependencies that you load from NPM. And then you have all the bugs in your applications. The frameworks are open source, highly extendable, and there are tons of plugins and tons of third-party libraries. So when you pull all of that in, what's the quality of the third-party code? Not always as good as the quality of the framework itself, right? So those are the risks that you're facing. And then, yeah, sometimes you don't get good documentation. You have to get into the source code and find how things are actually working, et cetera, et cetera. But the reality, what can we do? We cannot stop using the frameworks. Come on, right? They're there to stay. Nobody's going to write vanilla JavaScript code, or TypeScript code, right? Not anymore. So, of course, we have the client-side JavaScript and the server-side JavaScript. Kind of quick overview here. If we're looking at the security issues for the client side, of course, yes, cross-site scripting, number one, still there. The DOM kind especially. If the framework has expression language, and like Angular and Vue do have expression languages, you have the new expression language injections, right, which usually end up in a cross-site scripting as well. We have, of course, clickjacking, and now we can do a CSV clickjacking where you don't even need to use any JavaScript, right? You just add an element with your like a CSV button on top of some element, and you collect the clicks and do whatever you want, can change the UI. There's DOM clobbering. That's not something new that's been around for more than 10 years, or 8 years, so the DOM is super, super messy. And if you have one element with an ID, and then you add and inject another element with the same ID, now you get a collection of IDs. That's how browser interprets them. And of course, the properties now change. You cannot access the methods of the original item, and yeah, you can do pretty bad stuff with that. Client-side trust issues. So with the JavaScript frameworks being so heavy on the client side, you move so much logic, business logic, onto the client side. And sometimes you may be trusting the client too much, having too much data, or having your authentication authorization for some reason on the client. I mean, that's so widespread. CSRF, of course, that's a server-side vulnerability, but we have the features in some frameworks that sometimes help you protect from it. So there's like the client element where you have to take the token and plug it, put it either in the post parameter or the HTTP header. And some frameworks do it automatically for you, like Angular does. Some don't, and then you have to use some third-party library or implement it yourself, or use JWTs, and we'll talk about that later. And then, of course, there's information leakage. Again, trust of the client. You're loading too much data. You're putting it on, local storage or something like that. So server-side vulnerabilities are not as exciting because pretty much, server-side JavaScript, Node, and all the frameworks that come with it the vulnerabilities are the same as any other server-side language. You have your injections, a ton of them. You have, of course, if you're using NoSQL database, you have the NoSQL injections that are different from the SQL injections. CSRF, the server-side part of it, the validation of the token. Remote code executions with JavaScript are fun because we have the eval, right? And then, auth and auth z, the deserialization, the new thing in the OWASP top 10, which is quite common in JavaScript because we have eval. And again, we'll see some examples of that and all this stuff. So this is not the focus of today's talk, right? So we're going to concentrate on the client side. And if we look at the newest OWASP top 10, which of the things apply to JavaScript, to the client-side JavaScript? Right? Let's see. Injections, of course, we have expression injection. Not SQL, not LDAP or command, but we have expression injection. Broken authentication, yes, if you do it on the client side. Sensitive data exposure, yes, if you're trusting the client. XML entities injection, probably not. I mean, most of the JavaScript frameworks you are using JSON, and then even if you are using XML, you're not using the same parsers on the client side. So at least here we can have a break. Access control, yes, if you implement it on the client side, wrong. You will have problems with that. Misconfiguration, if you're using a framework that has settings, security features, and you misconfigure it, that's a problem. XSS, of course. Insecure deserialization, yes. So again, it happens more often on the server side, but you may have it in your client-side code as well, and we'll see some examples. Components with known vulnerabilities, of course, if we're pulling everything from the NPM and all the tons of vulnerabilities, tons of open source projects, I should say, of course, you're pulling that into your environment as well. And insufficient logging or monitoring, I mean, on client side, not so much, but you have, if you use like an analytics website, right, you're sending your stats somewhere, that's where your logging and monitoring may come into play. Or CSP, and you're like report the bypasses. Right? So what do frameworks give us in terms of security? So they have pros and cons. They have the good things. They may have security controls built in. For example, a lot of them, JavaScript, will have contextual encoding, escaping, whatever you call it, right? Like Angular, like Vue, like all the templating engines will do contextually aware encoding, knowing where you're outputting your user data. Is it a URL parameter? Is it HTML entity, an HTML attribute? We're good here. CSRF protection, as I said, for example, Angular, if you set your cookie, XSS cookie, CSRF cookie name in a way that Angular is expecting, it will take that cookie and add an HTTP header, and then you again read that HTTP header from the server side as long as the names match, and you can configure it either on your server side or on the client side, right? So that's taken care of for you. Type checking. Some frameworks add a feature that you would actually use types in JavaScript, the wonderful loosely typed language. Like React has the type props library that will allow you to actually set the types, or if you're using Angular 2 and up, you're using TypeScript, even better. Sandbox, which is not a security. Here I'm referring to the Angular sandbox, which is not a security feature. That was, there are tons of sandbox bypasses, et cetera, et cetera. But some frameworks try to protect you from the bad stuff that XSS can do, successfully or not sure. And then whitelist. Some frameworks will have features. For example, Angular will have a feature where you can configure where you can load your resources from. You can whitelist a list of domains. And so these are just some examples of the security controls that are built into the framework, helping us to write better code. But there are also some insecurities that come with the use of frameworks. Expression injection. If you have an expression language in the framework, right, you can have a new type of injection there. Sandbox can be bypassed. Insecure APIs. So sometimes a framework will have a dangerous API that shouldn't be used, like trust as or dangerously set inner HTML in React. But they're there, or eval is not a framework API, but things like that, right? So they exist, and those would be the things that we'll look for as security code reviewers. And CSP bypasses. Again, you may use the framework that compliant with the CSP, and you may have strong CSP policy and not have any inline scripts, et cetera. But some of the frameworks actually, you can bypass CSP and inject a script. Well, not a script. You inject a framework element that's then interpreted by the framework code and then results in a script injection. Like jQuery has that. Ember had some. Angular obviously had CSP bypasses. So you're bringing that into your application as well. So that's the overview, and let's talk about React. As Jim said, why we're talking about React? Well, that's the hot framework today. If we look at the NPM stats for downloads, React is way out there. Of course, Angular was pretty popular. Vue is catching up. It's still pretty low there, but it's actually growing pretty fast. So for a year from now, it may bypass React or be somewhere in the middle. So that's the other new stuff that's coming up. So React was introduced in 2013. A little bit of history here. What was the world, the view of JavaScript in 2013? Well, AngularJS was super popular. Everybody was writing in Angular. And React came out with a few features that Angular didn't have, or actually React said, well, the way you're doing this is wrong. We're going to do it a different way. So one of them, the one big one, was one-way binding versus two-way binding, right? Angular had two-way binding where you update the model, the UI updates, you update the UI, the model updates. Great. But it was very hard to maintain and very hard to scale. In big applications, it became just created a mess. So the React developer said, we're not going to do that. It's just going to be one way. The model updates the UI. That's it. They also introduced their own templating language, JSX. and decided not to have an expression language, but instead have the JSX, and we'll look at that. And they also introduced a virtual DOM, which allows you to render React on the server side, and then just send the plain HTML that's going to be displayed in the page right away. The other thing that made React so popular was that in 2014, the Angular team said, we are going to release Angular 2, and that's going to be a totally breaking change and basically a new framework, and everything you're writing right now in Angular 1 is not going to be compatible, and we'll have to rewrite it again. All right. I mean, that's not like the first time we saw something like that in the field. But the Angular 2 took 2 more years before it was released, or I'm sorry, a year before it was released. But a year in JavaScript world is a long time. And because there was that insecure, well, I don't want to use the word insecurity, but like kind of unknown situation of what's going to come out of Angular 2, a lot of developers actually switched to React. Because it was out, we knew what was going on there, what are the features. Developers didn't want to continue developing the applications in Angular 1 or starting developing in Angular 1 because Angular 2 was coming out. And that time frame actually allowed React to become super, super popular. And of course, it's backed by Facebook, so has good support and good documentation, surprisingly. So the talk is kind of about JavaScript frameworks, but React is actually not a framework. If we look at the documentation, it is a library. It is a user interfaces library. And I think that's just terminology, because realistically, if you ask, okay, what is your application written in? It's written in React. It's written in Angular. It's written in Vue. You can kind of use them interchangeably, so kind of as a framework. But the reason, kind of one of the reasons why it's not a framework, it doesn't have the full functionality that would allow us to call it a framework. So it's not opinionated in many things. For example, it doesn't have the routing built in, right? It doesn't have like CSRF protection. It doesn't have originally kind of like the state management, although everybody's using, well, not everybody, a lot of people are using Redux with React, although you could use something else as well. And because it doesn't have a lot of these core components built into the framework, it actually allowed to create, well, it kind of created a surface for a lot of plugins and libraries and have this vibrant community of third-party developers building plugins and features for React. One thing that it is very opinionated in is the functional programming. It's not kind of fully functional programming because it's not a language, right? But it has these concepts where everything is a function. So if we look at the component is actually a function. So we pass some properties, which then become the values of the attributes that we set on the HTML element. And here is our JSX that looks kind of like HTML, but not really. That is later rendered into the actual HTML. So let's start with cross-site scripting. We're talking about client-side framework. Of course, number one vulnerability will be cross-site scripting. So React has the contextually aware escaping. So if you're trying to inject something that contains a script, hey, Birdie, gets excited by my talk. Thank you. This is like in like third grade. You have a bird fly into the classroom and completely disrupts the lesson. Awesome. So if we're trying to inject some malicious input and we put it into our curly braces, it gets escaped, all good, because React actually does not use the inner HTML, doesn't change directly the inner HTML property. But what if we do need to change that? Of course, there is a way. And we do that by using the dangerously set inner HTML. And that's kind of another interesting thing that when Angular 1 is out and they called that had the same functionality and they called it trust as HTML or URL, et cetera. So I trust this code. Where React said, no, this is too not scary. because you're actually doing something super, super scary. So we're going to call it dangerously set inner HTML. And then Angular 2 came out and said, oh, OK, we're going to do that same thing. So we're going to say bypass security trust HTML. That kind of makes me think about that first slide where, how do we write JavaScript, where your function names are like German words, like 4 different things together. So React doesn't have expression language, so it doesn't have expression injection, yay. But it creates components, and if we are creating components on the fly dynamically, we may have component injection. So let's look at how the components are created. So we can write them in the JSX, where we have the tag, we have the attributes, the values of the attributes, our properties or props in React language, and then we have the content of what's inside the tag, and that would be the children, the child property here. So that the JSX code gets transpiled into JavaScript, and when it gets transpiled, this is what we get, or we can actually write it like this, but nobody does it because this is ugly. So we have the first parameter, which is the type, h1. We have the second parameter, the properties that we're passing, for example, the class name here. And then we have the array of children. So in this case, we're passing just one text node, hello world. So these are the 3 points where we may be able to inject something if we're creating a component dynamically. So the first XSS that became known in React was actually found on the HackerOne website itself. I think this is super cool. And that was the problem not in the HackerOne website, but in the React framework. So it was possible to have an injection in the children property, right? So if we are sending some malicious JavaScript, malicious input into the children, like their attacker payload, we just said this is going to be escape, right? If we go back, we said, why can I not go back? Here we go, right? So we just said if we're trying to send some script, it's going to be escape. So, what do we do here? Well, we're not sending JavaScript in there. What we're doing, we can send a JSON object. And apparently, React, now it's fixed, right? But before, it would not only accept a string, that would be normal, but it would actually accept a JSON object. And you could have a JSON object that, to make something a JSON object, you would just have an JSON, a React object, you would just have a JSON object with the isReact element property that's set to true, and then a couple other properties that you have to have, like state and the type, and then you're sending your props, and here's your prop with the set dangerously HTML, which is actually accepting an object with the property underscore underscore HTML, and there's your payload, right? So that worked. And then was fixed in React 14. So after that, you cannot inject an object into the children. It has to be a string. So that's good. So the children injection is fixed. Now we have 2 more properties here. We have the type, and this field is still injectable. But this is just the HTML type of the element. So what can we do? We cannot inject any attributes here. OK, so you may inject another header, you may inject another div, you may inject kind of break or image, but you cannot inject any properties. So it's pretty useless, right? You can't do anything about it. The good stuff is the props, which is still injectable. So if you are passing untrusted input into the props element, then you just set your property to dangerously set inner HTML and pass your input. And your input should be an object with an underscore underscore HTML attribute name and then kind of your payload. So this is one sync, as in our the code review terminology, we say that we're looking for. If we are creating the elements dynamically, this is one place where you definitely have to look for untrusted input. The other problem, the other XSS vector, are the injections into the attributes that allow JavaScript execution already. And most common of them are the attributes that accept URL, so URIs, because you can, of course, inject the JavaScript schema URI and inject your payload here. So it's not only the href tag, that's kind of well known, but HTML5 also introduced a couple things like the form action for the button or the poster attribute for the video and audio. Now it's fixed, but used to be a problem as well. So instead of the poster, the URL to an image, you could also inject the JavaScript URL. And also another HTML5, new HTML5 feature are the imports, the JavaScript imports, because in your header, you could inject the imports, links to the other JavaScript files that would be loaded into your page. And so if you create those dynamically, then if your user input goes into this href for the link element, then you can also execute JavaScript. How do we fix that? Well, you have to strip out the JavaScript schema, right? You can write a simple regex for that, or a better way to do it, just use a library that will parse the URL, and actually you can then verify what is the protocol of the URL that you are injecting. Right. And yes, I know these things make Jim very, very, very angry. Right, Jim? All right, so let's look at some examples. Yes. The moment of glory. Right? Okay. So here is a sample JavaScript React application that we use in our ILT training. And if we create a new post with the name LocoMoco, and we specify the URL, right? Looks good. And then when we try to visit the link, we have the pop-up injection, of course. So if we look at the source code, what's going on here is that we are creating a new post, and then we are sending that URL from the server side that we didn't validate on the client side, and we're creating a new component here with React and sending that URL property. And then if we look at the component itself, then we're creating an tag with an href that takes our URL, right? That's where injection happens. So we were setting the href to something that is not trusted. We don't have any validation, and that becomes a problem. Actually, this code has another vulnerability. So if we look at this a tag here, then, so we set the target, we set the href, we set the class name, and that's pretty much it, right? So what else is wrong with this? With setting an a tag to an unknown URL. I'm sorry?
If the untrusted URL is a JavaScript scheme, it completely
yeah.
all the React security.
Right, so I talked about that. Like that's number one. What else? So that untrusted URL, when a user clicks on it, the browser will set a refer header from your site that is going to go to the third-party site, right? And depending on what information you have in the refer header, you may be leaking some, pretty interesting stuff. So it's not kind of as bad, but yes, there's that as well. So let's go back to the slides. So the next type of XSS, again, still an XSS subject, is the XSS with Markdown. Well, if we need to display some rich text with, bold, italics, etc., if we're writing a CMS, Going back to the example from this morning, right? And we need to have this rich content. One way to display it is to use Markdown. Awesome, because it doesn't have any scripts, all good. Well, how do we display a Markdown in an application? Like if React out of the box doesn't have a feature to display Markdown. So you will use a library that will convert your Markdown into HTML, and then you need to display it on the page. One example is the Showdown library, and what it does, converts to HTML. And then to display it, how we display HTML? You have to use the dangerously set inner HTML. But we're good, right? Because we're using Markdown. So we should be safe. Except, what if your Markdown contains a script tag? The problem here is that the Showdown library, or whatever kind of else you're using, is not going to strip out XSS. It's not going to strip out HTML scripts or HTML tags before it converts it into HTML. It's just going to take it as they were in the source and put it into the output. So that is even more dangerous, because you look at the code and you think, wow, they're using Markdown. Good, right? It gives you that sense of security. But actually, if you don't validate your Markdown coming in, and it contains a script tag, an image tag, or whatever, it's going to end up in the output as well. So again, let's look. And the solution, my clicker today, it's not clicking back. Right. Solution, use DOM HTML Purify. Thanks, Mario. Because again, Markdown by itself will not do that for you. So let's look at the demo. So here I have my little application where I'm typing some Markdown, all good. But if I'm trying to embed an HTML tag, done, right? So let's look at the source code, because that's more interesting than just saying a pop-up. So here's what's going on the client side, right? So we're getting this Markdown from the server. We saved it on the server, didn't do any validation, because we know it's Markdown, kind of. We convert it into HTML, and then we return it as an object with the HTML attribute, and then later in the code, we set it into the dangerously set inner HTML. And so if our Markdown contains some XSS, it's going to be right out there. So to fix that, we just use a sanitizer, for example, the DOM Purify. And if I can find the right build here. But basically, it fixes the issue. Right? So don't think that if you're using Markdown, it's going to save your world. Yep.
I've heard many times that Markdown eliminates XSS. It's written all over the place. This really breaks most conventional wisdom. And I see a lot of people going, what? So can you give us a little bit more on that? Or that really disrupts a lot of things I've read on the topic.
Right. So if you're using pure Markdown, right, it doesn't have a way the language itself, right, doesn't have a way to input a script. But the problem, it's not kind of the problem with the Markdown standard, the Markdown itself, but with the Showdown library, or like some other libraries as well, that when it converts Markdown into HTML, if you have script tags or image tags or any HTML tags, it doesn't say, oh, this doesn't look like Markdown, just kind of remove it or show an error or something. It already has the tags, so I'm just going to take it and put it into the output. Because the Markdown, this converter from Markdown to HTML is not the HTML purifier, which is dumb, I think.
So you're saying go from untrusted Markdown to HTML, and then go from HTML to DOM Purify, and then render.
Yes. Well, but I would say, why would you have an untrusted Markdown? if you're saying your user can write Markdown and you're storing Markdown into the database, why don't you do the little check right there? Is it actually Markdown, or does it have your angle brackets, et cetera? But for that, you basically need like a Markdown purifier. I don't think so. I mean, yes?
There are, but not Java. I mean, there may be in JavaScript, but the one I'm thinking of is in Go.
In Go, okay. And Mario, you had.
I think the problem is with Markdown is the same problem that we had a couple of years ago with VB code. Because with VB code, we also said that, oh, we have subset, it's a secure subset, but we just inject into VB code and produce HTML was vulnerable or malicious. And the Markdown is the same. You should not see Markdown as something that is a secure subset.
Yeah.
Just as something that is a subset. Because the Markdown has the VB code values, they don't care what it's true.
Mm-hmm.
It's not their job, they just produce something from something, and they have no idea what's security that comes from it. So Markdown has nothing to do with security, it's just a subset that can be extended beyond that subset. So you need to do it right.
Yeah, thank you. Thank you for the addition. So basically, Markdown is not a secure subset of HTML, right? Markdown is just a subset of certain features of HTML, and we shouldn't trust it. We shouldn't use it as a security feature, right? So it's just a subset of HTML. And if you inject into it, you're going to have the injection, because it doesn't do anything to prevent you from that. Yep.
So there is something called common mark that uses, or CMark, and there are JavaScript implementations that provide a very strict proper parser in tacit instructions to not pass through any HTML.
And is that in Go, you're saying?
No, there's common mark JS.
Common mark JS.
But
Yeah.
it's on client, right? We should not trust client. If you put it on client, it's like, it's meaningless. Because I can inject the client, right, to the server.
I mean, if
You're saying that you're storing it on the server, right?
so,
JavaScript for validating Markdown doesn't make any sense.
well, unless your server side is written in JavaScript, then you can use a JavaScript library on the server side. But yes. Yes, you can validate it on the server side before you store it in the database, right? Or, I mean, you can use the DOM purifier on the client side before you output it to the page. After you got the data from the server, and then you clean it, and then you put it out. And that's fine as well.
Yeah, but what I'm saying, you can create a client which is not a browser, which doesn't have any JavaScript, and directly inject it to your server. And after that, when you
If your client is not a browser, then, I mean, that's a different story, right?
if I'm a Markdown, you can do that, right?
Yes.
Just by parsing. So validating on the client doesn't make any sense.
It's a longer conversation. Let's get to the slides. So server-side rendering. So that's another feature that React implemented and that kind of made this framework different from others. So what's going on here? Well, because our client is becoming heavier and heavier, the initial load of the page was taking longer and longer. That's one thing. So performance was an issue. So then React developers said, hey, the initial page that we show to the users doesn't have to have any events attached to it or any interactivity first when the user just starts looking at it, right? We can add the events and interactivity in the next few seconds, but that will have the perception of the page loading very, very fast. So performance was one concern. And then the other problem with React and other JavaScript frameworks is the search engine optimizations becomes more complex. I mean, there are ways around it, but out of the box, the SEO is not as great. So we kind of decided to switch the architecture, right? So in this case, we are rendering the HTML, the code on the server side, and then, or HTML and JavaScript, right? And then sending the HTML that needs to be just displayed in the browser right away, and then we attach the events later. So that actually becomes very similar to the old server-side templates, to your GSPs, Smarty, whatever, right? Where you render that on the server side and then send the HTML to the browser. So kind of the idea is not new. It's new for the JavaScript client side, but it's not new in programming in general. And what does it change in terms of security? Well, in terms of security, actually, before we get to security. So server side, right? So what happens is that we are rendering the HTML on the server, and then we're sending it to the client side, and we start displaying it right away. And as we're displaying the page, we're loading the JavaScript, and then we're executing React, having all the linkages, all the bindings, all the events, and then the page becomes interactive at the end. With the client-side rendering, the difference is that, we create HTML, then we send it HTML with all the JavaScript dependencies to the browser, so then the browser takes time to load HTML, then to load all the JavaScript libraries, then to render everything with React, and only then we display it. So that kind of adds a second, 2 seconds, and that's a lot of time in our world for JavaScript applications. So what does it change in terms of security? Well, one is now if you have untrusted data in your HTML template, when you're rendering it on the server side, if you're injecting something into it, you're injecting that on the server side before all your React protections, before they are enabled. So you may still be able to have kind of a plain server-side injection as you had before in any other server-side template. And then the other thing is that the data is added directly to the DOM, without the React bells and whistles. So let's look at an example. It will make kind of more sense here. So server-side rendering. So create the React elements, create the React application. We render it on the server side, send the HTML, but to make the HTML alive, we need to send the state. And to send the state, the way we do it, and state will be just your JSON object with all the props or whatever data you need to send. And to send it, the way we do it is we set a global variable to the window. It's usually called a preloaded state or app initial state or state, just kind of all the different names, whatever. And we just set it to that JSON object right there. So that happens before React is loaded. So, all right, what if I have user input into that JSON object? Well, if I'm trying to inject something into JSON, like I would say I would like to inject JavaScript, so I need to break out of the JSON context. So I try to inject double quote, gets escaped, doesn't work. But if I inject something like that, I mean, from the JavaScript perspective, I'm still good. I'm still in double quotes. I didn't break out of my JSON object. But the way the server, the browser is going to render it, it's going to pick up the first script tag, and then it's going to pick up the closing script tag and say, that's it. The script is done. And then it's going to render my alert as the next script. This is just the quirkiness of browsers. Kind of this is how it works. And there you have your injection, which is funny because you are injecting into JavaScript context. So you shouldn't need a script tag, right? We always say, like, oh, the injection is according to the context. We should just inject the JavaScript. But that's actually how it works with the browser. So, and the biggest problem with that is this code example on top here without any protection isn't any tutorial on React. Yep.
It's just like a browser bug. The script is in JS context. It should be accepted.
Yeah, that's but that's the browser. I mean, that's how it interprets the JavaScript, right? I mean, not the JavaScript, so the HTML. Yeah, right. So yeah, thank you, Dev. So the browser parses the HTML first and says, okay, opening script, closing script, opening script, closing script. It doesn't know that the double quotes, like this is still the JSON object that I'm trying to create inside the JavaScript. So yep, the embedded context get very, very messy. So let's look at an example here. Oh, I'm already in this mode. So. Oh, come on. Demo gods. I have a complex password. It's not 1, 2, 3. So here's my application that renders on the server side. And if I'm sending a, just a URL parameter, it renders on the page, all good. But if I'm sending a script, as I showed you, right, I get an XSS, nothing interesting. So let's look at the source code here. Well, first at the page source. So the interesting thing is that the injection happens not in the React code, right? That injection of the state, where we say window, app initial state, this is before the React app. So this is just kind of pure old HTML with some JavaScript. Yep. Sorry. There's no templating language. So. Oh. You may be using a templating language like EGS, depending on what your server side is written in, right? If it's Node code, you will use EGS, Jade, whatever. Nothing standard. If you're writing this in Java, you'll just be like, whatever. It doesn't matter, right? So if we'll look at the location where this information, so the injection is it working? You can see the pointer. But yeah, so the injection is right here, right? If we're looking how the React interprets that payload, it actually does all the encoding. So it's kind of like it's not the React's problem, really, right? So React says, like, well, I did my encoding. I didn't do anything. So once that is inside the React template, it's all encoded. But the problem is that we inject the state before the React app. The state is, and the React app needs the state when it loads. So it should already be in the HTML page. So if we'll look at the code here, right. So we are creating our state here, and I'm taking my, so I have the JavaScript server-side code, Express, nothing fancy. So I get my name from the query parameter, don't do any sanitization, create my state, send a couple parameters into it, and then I call this render to string. So this is the React function that renders the React DOM on the server side, renders it to a string, and then I'm using a template and passing that into the initial state parameter that is then injected into the index page. So here on the client side, the template here, right? So then I take that initial state and set it to a global app initial state variable. Right? So how do we fix it? Well, let's look. Oh, before we get to the fixing question. The other thing is, so that was the server-side rendering without any state management on React, right? We just have our state in the JavaScript. Well, what if you're using Redux? Same problem, right? Same thing. If you're using Redux, you still have to set the state initially. And like all you do is you do the JSON stringify. And you do it in the previous example as well, just kind of earlier in the code. And again, the problem with the Redux was that this code, this vulnerable code, was in their documentation. Like that's like if you look for how to create, do SSR with Redux, like that's the code you're going to get until it's like what 2015, I think. Emily Smith found this vulnerability, reported it to Redux, and because it's not an issue in the Redux, it's just kind of the issue in their documentation. Now they have, on this page, they have on the bottom little section that says security concerns and says, by the way, if you're doing it right away, you're going to have a problem, and this is how you fix it. So instead, just use, dot replace, and you escape any less than character, whatever. So that's the fix that they are proposing. Of course, I would say a better fix would be to use a library that will just serialize JavaScript. So for example, the serialized JavaScript library will basically encode your scripts into JavaScript context, and that will fix the issue. So the next, how are we doing on time? Ooh, all right, sorry, I'm gonna speed up. So the next vulnerability is, again, eval. How many eval problems can we have? Well, as long as we have eval in JavaScript, there are going to be issues with that. Again, this is not React specific, actually, but we see that. So going back to the serialized JavaScript library that I just said, use it, it's awesome. Well, what it does, it serializes JavaScript. And if you serialize something, you may want to deserialize something. Well, the serialized JavaScript library doesn't have the deserialize function in it. And instead, what they have is they have this wonderful piece of code in their documentation, on their README page on GitHub, saying that, hey, if you want to deserialize something that you serialize, do it like this. Just put it in the parentheses and call eval on that. What can go wrong? And I think they didn't include this function into the library just so that they didn't have to fix it. Nobody could say, hey, you guys have an issue. And the problem is, there's no way to fix it. That's the issue. It's not like we have a function that's called safe eval that's not going to evaluate your JavaScript in there, right? If you are using something like that, it's probably a design issue, and you have to redesign your application the way you're using it. Or again, you're validating your input first, and you know that whatever I'm sending to the eval is super, super safe. But who's going to say that? Who wants to lose their job? Another new location for using eval that I saw, so this was on Stack Overflow. So the question was on Stack Overflow, well, I want to send some JSX to my application from the server side to the client side, and then render the JSX and update my React app on the fly on the client side. How do I do that? And that was the recommendation, use Babel, convert it, and then do the transformation, and then just eval the code that Babel converted. Well, right, what does this code do? Well, first of all, if you're using Babel on the client side, that's already a big problem because Babel is super heavy. That's not helping your performance. And second, now you're evaluated code that, I don't know where it's coming from and what your JSX may contain. And then, of course, we still have the parsing of JSON with eval, much less so, because, of course, finally, developers started using JSON.parse and not do just eval, but that sometimes happens in the legacy applications. And another problem with eval is that it will not let you create a strong CSP, because if you're using eval or your library is using eval, you have to say unsafe eval, and kind of you're breaking all the protection again that you just implemented with CSP. So React can communicate, communicates with the server. The functions are slightly different. It's using the new fetch, well, not React, but developers, right? Usually use the new fetch function that by default makes a GET request. And funny enough, the code that we have seen, sometimes developers use the fetch function, the GET request, to change state on the server. Because it's simple, right? Unfortunately, that happens. And this is kind of the API, and it's like, oh, it's just going to be a GET, and then the API is actually, change user profile with the GET request. Problems come out of here, so you should use a post request. You should have the request authenticated. By default, the fetch, if you set it to a post request, will not include the cookies, so you have to set the credentials parameter, and you either set it to same origin or include. If you are using course, that's when you're going to use the include, right? Then you're going to send your cookies across the origins. But by default, if you're not using course, you would set it to same origin. Or if you're don't use tokens, you're using JWTs or whatever other tokens in the headers, you would set an authorization header in the headers with the fetch function. And then the next problem is leaking sensitive data into the client side. Talked about that a lot of times. The reason why this comes up in React. So this is, again, a bigger topic. I'm just going to mention it. But because React doesn't implement CSRF protection, the kind of the client-side part of getting the CSRF token and then adding a CSRF header or something, developers still need to solve this problem. And one of the solutions that everybody says, like, well, just use JWTs, JSON Web Tokens. Then you're not using cookies. Then you don't have CSRF. Wrong. JWTs are not meant to maintain sessions. They have a bunch of other problems. I mean, I'm not saying they're bad. They just have a different use case. And then also you should implement them correctly, sign them, have the right expiration times, et cetera, et cetera. So, but oftentimes the React applications are using them. And where do they store them? They will store them in local storage. You cannot tell them to store it in session storage because, OK, this is a single-page app. It shouldn't have a page refresh or another tab, but nobody's code is perfect, and application will still use a refresh, and then your session storage is gone. I mean, you cannot make your user log in every time they open the app in the new tab, right? So you're going to end up using local storage. So from the pen tester's perspective, your payload now is not going to be, script alert, but it's going to be something like that, right? You're going to say, hey, local storage.get item, JWT token or OAuth token. So we're now looking not at the cookies, not document.cookie, but at whatever is stored in the local storage. Solution, don't store anything sensitive in local storage. But if you are using JWTs, make sure the duration is not long. You're refreshing them. Again, that's a separate topic. It's a design issue, right? It's not something we can fix with just line of code. So do's and don'ts if you're using React. Kind of to sum it up, don't use eval, don't use dangerously set inner HTML. If you are using it, use DOM purify, validate your HTML before you're setting it to the page. Don't use untrusted input when you're creating the URLs, when you're setting the href or form action or something like that. Don't create components dynamically. If you do, validate whatever you're putting into the props. Make sure user cannot inject the dangerously set HTML into the props. And don't store sensitive information in local storage. Do's, perform JavaScript encoding if you're using SSR, right? So for that state should be serialized first before you set it to the global variable in JavaScript. Use authentication on your post requests with fetch. And do use types. I mean, in React, you can use the prop types that will make your code cleaner, a little bit more secure for the properties at least. And you can also use the ESLint plugin for React that has a bunch of rules, mostly quality rules, because ESLint is not a security tool. But there are a couple rules that actually will identify low-hanging fruit, or at least show you points of interest where you can kind of look into the code and investigate, is everything right? So here's a subset of the ESLint properties. It allows you to find everywhere where you set like the dangerously set HTML, it's the no danger rule, or DOM elements with no children. So if you have a DOM element like a image that shouldn't have a child, right, and you are setting children to it, probably something is wrong with the code. We should investigate that. That's, again, on the security review standpoint, like what we will be looking at in the React applications. And I'll set a rule. So the forbid DOM props allows you to configure any DOM property. If you're setting it in React, it will flag it. So I would always configure something like that. href form action, if we're setting something with that, with href, it's probably an interesting place to look at. And that's it. So any questions? Oh, why don't we store sensitive data in local storage? Because if you have XSS, done. Well, actually, that's one thing. But another thing is that it is there. I guess I didn't mention that. If you are storing something in local storage, you should clear it out when you log out of the application, right? So that when you close the application, it's not there anymore. The time, you should expire them, yes. Right. So there are multiple things, right? You would set the duration of the session shorter, or you would clear it on logout. But there are other things that you may store in local storage, like well, you can have a refresher token that has a much longer life, right? So for things like that. But yeah, but in XSS, it's still another issue. Like if you're still on the page, you can read it. Right. Yes. The question was why, while storing something in the local storage, well, not something, but specifically a session identifier in the local storage is a problem, right? So one is that, if when you close the application, it is still there. And then the question is, how long is your session duration, right? How long this ID will be good, still good for how long, if it's stolen later. So you can mitigate it both ways, right? You can just set the duration of the session much shorter, but then if you are having like a refresh token that will have a longer life, and you store that there. So from kind of what we recommend is we still recommend using cookies on HTTP only to prevent that. But yes, then you will have to use the CSRF tokens to prevent CSRF. So it's not a one-size-fits-all solution, obviously. Any other questions? Cool. Thank you.